Uh, Hello and welcome again. This is video number 8, which is in continuation of the chapter chemical reactions that I have covered in 7 videos so far. In this video number 8, we are going to start with the reaction of metals with oxygen, right? So in general, any metal will combine with oxygen to give you the corresponding metal oxide. This is what in general happens with any metal. Now, metal will combine with oxygen when we are trying to burn the metal in air, because air contains mostly oxygen. So when you burn the metal with metal in air, okay, what happens? The oxygen from the air combines with the metal. Now, suppose if you take magnesium and if you want to combine it with oxygen, you will get magnesium oxide. And if you try with zinc, you will get zinc oxide. With iron, you will get iron oxide. With copper, you will get copper oxide. Okay. So any metal combining with oxygen will give you the corresponding metal oxide. Now, this investigation or this experiment has to be carried out with the help of tongs. Okay, so you have to hold the metals in the tongs, and you have to use something called heat-proof proof mat, and you have to wear safety glass, right? Now, on performing this investigation or performing this experiment, you will see that the reactivity of the metals, okay, reactivity with what? Reactivity with the oxygen. It differs, okay. So we will find that the magnesium reacts faster than iron, or you can say iron will react slower than the magnesium, okay. Same way potassium and sodium. Now these are not performed as experiment because potassium and sodium are very highly reactive with oxygen. So these, if you try to perform the experiment, you will not be able to do it because it is very dangerous and risky. Okay. So potassium and sodium, they are very highly reactive with oxygen, and therefore even before it is heated, they start reacting with the oxygen. This potassium and sodium will start reacting with the oxygen, and it will form the respective oxide. That is, if it is potassium, it will form potassium oxide. If it is sodium, it will form sodium oxide. But these reactions are highly reactive and they are explosive. They are explosive because in this process, now these reactions are not there in your syllabus, but let me tell you, in this chemical reaction of sodium and potassium with oxygen, okay, what happens is hydrogen gas is given out, okay, which explodes, right? And that is why it is not good to carry out this reaction in laboratory. This is the reason why sodium and potassium, now these are the symbols of sodium and potassium. Sodium is Na, potassium is K. Okay. So this is the reason sodium and potassium are kept in oil. Now they are kept in oil to prevent them from coming in contact with the water vapor and the air. Okay. So water, this sodium and potassium, they react with water forming hydrogen. Let me tell you that. Sodium and potassium react with water forming hydrogen gas, and that is why water vapor in the air, okay, will be reacting with this potassium and sodium to explode, and that is why they are kept in oil, right? Gold and silver are metals which do not react with oxygen, okay, nor with water, so they are termed as inert metals or inert elements, okay. Other name for inert is inactive. Okay, they are not active, they are not reactive, they are inactive. Silver is a metal out of gold and silver. Silver is slightly reactive with oxygen. It will combine with oxygen forming silver oxide, but it is a very slow process. Okay, so silver oxide, which is black in color, forms a black layer on the silver when it is kept exposed to the air. Let us move on to the next slide, which talks about the reaction of iron metal with oxygen. So here we are going to study the reaction of iron with oxygen. Okay. For this, what we will do, first let us understand this word equation. iron plus oxygen will give you iron oxide. This iron oxide, the product form, is known as rust, and that is why this process is known as rusting of iron. Okay. Now, rust is nothing but iron oxide. This rust is a alternative name for iron oxide, and the process of forming iron oxide is known as rusting of iron. Okay. Now, rusting essentially requires two things: water and oxygen both. Okay. Water is acting as a catalyst only. It is not responsible for rusting, but it helps as a catalyst. It will make the reaction happen fast. It is a very slow process. Rusting is a very slow process because iron is very low in reactivity. Iron is in reactivity series, it comes very low. Okay, so it is the least reactive metal. Iron is the least reactive metal. Magnesium is slightly more reactive than iron. Okay, and sodium and potassium are highly reactive. Okay, so iron being very least in reactivity, so it will not combine vigorously with oxygen, and therefore this process of rusting is a very slow process. Let us try to understand what are the factors that is responsible for rusting. So, or you can say what are the causes for iron to rust. Okay. For this, what we will do, we are going to take 4 test tubes. Test tube number 1, 2, 3, and 4. In these 4 test tubes, you are taking the same dimension, same size iron nail, and you have placed in all the 4 test tubes. In test tube number 1 and 2, which are open, they are not closed from the top. In test tube number 1, you are keeping only this iron nail, nothing else, right? In test tube number 2, along with the nail, you are putting some water. This is water. Okay. In test tube number 3, you are putting only some calcium chloride. Okay, CaCl2. This is calcium chloride. And in test tube number 4, you are going to put some boiled water over this nail. Okay, boiled water. This is boiled water. And above this boiled water, you are going to put some oil also. And above oil, you will see some space where there is some air present. And this test tube number 3 and 4 are closed from the top. Okay, they are not open, they are closed. So this arrangement is done, and we are going to see what is observed, and we are going to see what is the reason for those observations. Now, what happens in test tube number 1? Let us study in test tube number 1 what happens. In test tube number 1, the nail will get rusted. Iron oxide will be formed. Now, why iron oxide will be formed? Why rusting is possible? Because the nail is exposed to the air as well as water vapor present, the oxygen as well as the water vapor present in the air. So the air is coming in from the atmosphere, and this air contains both oxygen as well as water vapor. Okay, both are present in small quantity, of course, but they are present. So these are the two culprits which are responsible for rusting. See, here I've written rusting needs water and oxygen. So both are, the nail is exposed to both the things, oxygen and water vapor, and therefore rusting will take place. But being a slow process, the rusting will happen very slowly. So here the rusting in test tube 1 will take slowly. In test tube number 2, we can see that water is present. Okay, so water being an catalyst, it will act as a catalyst, and oxygen also it is getting from the air. Okay, so air is entering into this test tube and it is having oxygen. So oxygen and water both are there, and water is in larger quantity present over here. So rusting will take place very fast because water acts as a catalyst. So air plus water will help the rusting process to become faster. In test tube number 3, you will see that no rusting takes place. Why? Because first of all, the test tube is closed from the top, so no more air is entering. Only the trapped air is responsible. Okay, and in this trapped air, the water molecule or the water vapor, if at all is there, that will be absorbed by this calcium chloride, because calcium chloride has the property of absorbing moisture from the air. So this trapped air from this trap there, all the water vapor will be absorbed by calcium chloride. So there won't be any water vapor left in this particular test tube. Okay, so when there's no water vapor left, only a small quantity of oxygen will be left in this test tube, which is very, very less because the stopper is closed. Okay, so you have very limited amount of oxygen and no water vapor at all. So rusting is almost impossible, so not happening. So rusting will not take place because only dry air is there. There is no water vapor, and calcium chloride has already absorbed all the water vapor. Okay, and in test tube number 4, you will see that because of this boiled water, the water doesn't have any oxygen, and because of this oil which is kept above the water, okay, so that oil will prevent the oxygen from this trapped air to enter the water or to reach the nail. So here also the rusting will be very, very less. Okay, so this rusting will happen because there is some oxygen present in this boiled water, maybe some traces of oxygen, but that is not responsible for much of rusting. So rusting will be very, very low in test tube number 4. So this is the explanation of this investigation, what all things are happening and what are the reasons for these observations. So this was how rusting takes place. Now let us try to see some questions. There are some 8 questions, and let us try to do those questions first. Okay, so question number 1 to 3 we'll be doing first. So this is that question number 1. You can see on the screen. This is that question number 1. Okay. Which property of sodium and potassium is not typical of a metal? Now, sodium and potassium, okay, although they are included in metals category, but they are not behaving like other metals. Okay, they are slightly different from other metals in respect that these other metals are solid. Okay, if you see all other metals, they are solid, but the sodium and potassium, they are soft, and they are so soft that they can be cut with a knife. Okay, so this is the property of sodium and potassium, which is not typical of a metal. Any other metal you won't be able to cut with a knife. Okay, it's not possible to cut a iron metal or a zinc metal or any other metal with a knife. It's not possible. But this potassium and calcium, sodium, this can be very nicely cut with a knife. It is that soft. Question number 2 is, why is the scientist in the photograph wearing gloves to cut the piece of sodium? Now, these are the questions taken from your textbook, and in the textbook I have seen there's a photograph given in which the scientist is wearing gloves and is cutting the piece of sodium with a knife. So the question asks is, why he is wearing gloves? Obvious reason is the scientist is wearing gloves. The reason is sodium being highly reactive may react with the moisture on the skin. Okay, so suppose he is not wearing gloves and by accident suppose his hands, the hands of the scientist are wet, or it is having some moisture on his hand, then the moisture from the skin, okay, may react with this sodium, and that is an explosive reaction, and that may cause injury to the scientist. And that's the reason, for safety purpose, the scientist is wearing gloves. Question number 3 is, write a word equation, okay, for the reaction between sodium and oxygen. So word equation will be, you have to write in word sodium plus write in word oxygen, then arrow mark, and the product is sodium oxide. So you have to write only in words. No need of writing the formulas. Okay. So these were the first 3 questions. Now let us do the remaining questions also. And these are the remaining questions. Okay. So question number 4 is over here. You see this? Question number 4. Now the question says, what conditions are needed to prevent iron from rusting? Now you know very well that rusting happens in the presence of oxygen and water. So what should be done to prevent rusting of iron? You have to see that these 2 things are not coming in contact with the iron. So you have to stop the contact of water and iron or water and air. However, why air? Because air contains oxygen. Okay. So water and air should not come in contact with the iron, and if you take this precaution, then the rusting of iron can be prevented. Question number 5 is, which test tube and which condition caused the iron to rust most quickly? Now this is a question connected with that investigation that we studied in the previous slide. Now if you remember, in the previous slide, there were 4 slides. So in this slide number 2, you will see that the rusting is taking most quickly, because in the test tube number 2, okay, we had taken water as well as air, and the test was open. It was not having a stopper. So there was a lot of water, water vapor, and a lot of oxygen accessible to the iron nail in test tube number 2, and that is why the rusting there was very fast, because of the abundant quantity of oxygen as well as water vapor present. Next question is question number 6. Why is the same type of nail used in all the test tubes? Now it is obvious, it is for the test to be very fair. Okay, so if the nails are of the same size, same dimension, then the test that we have carried out will be a fair test. Then question number 7 is, how is the air in test tube number 3 dried? Now in test tube number 3, if you remember, we had taken calcium chloride. So this calcium chloride, okay, formula for calcium chloride is CaCl2, but you need not remember the formula. You can write in word calcium chloride. Now here I have written in short, you should write calcium chloride. Now this calcium chloride, which was taken in test tube number 3, okay, is responsible for absorbing all the moisture from the air inside the the air which is trapped inside the test tube. Okay, see in test tube number 3 there was a stopper, okay, and the nail was kept surrounded by calcium chloride. So the air which is trapped inside the test tube may contain some water vapor, and that water vapor will be absorbed by the calcium chloride, and absolutely there won't be any water vapor present in the test tube. So this is how the test tube air will be dried. Okay, dry means free of water vapor. So what is responsible? The calcium chloride that we have taken is responsible for that. Now last question is question number 8. How is the air in test tube number 4 kept out of the contact with the nail? Now in test tube number 4, if you see, okay, in that test tube number 4, so sorry, let me show you that slide itself. Okay, now remember the question is, how is the air in the test tube number 4 kept out of contact with the nail? So I'll take you to that slide of test tube number 4. Okay, and you can see here, this is that test tube number 4, right? Okay, so you can see very nicely in this test tube number 4, right? This test tube, the nail is kept in boiled water. So this is boiled water. Now when the water is boiled, most of the oxygen is removed from this water, okay, and over the boiled water there is a oil layer. Okay, so the oil will prevent the oxygen from this air which is trapped between the oil and the stopper. Okay, so above the air also there is some space in which there is some trapped air. So this air may contain some oxygen, and that oxygen may enter the water, the boiled water, but that is also prevented because of this oil. So the answer will be, why, how this oil is how this air is prevented to reach the nail. So it is because of the oil, and also because of the water which is boiled, it doesn't have any oxygen. Okay, so rusting will be next to impossible in that case, right? So answer to this, all these 8 questions now I have shown you. Okay, we have discussed all the 8 questions, right? The last question was this one, 8. So the oil layer keeps away air from entering the water and subsequently the nail. Moreover, the water is boiled, so it has no air in it. So air is already removed from the water because of boiling, and more air which is present in the trapped test tube, that is also prevented from entering the nail, okay, or coming in contact with the nail because of the oil layer. The oil layer and the boiled water both are responsible for keeping the air in, coming in contact with the nail. Okay, so that is the answer to this question number 8. And the next video we'll be discussing the further things, and this is the end of this video. Bye.